Straight to the graph. We're going to see if we can do this without the table of values. See how that goes. So here's x equals 1. If I'm looking at numbers less than 1, what's my graph look like? Yeah, I'm going to be going to the left, and I'm looking at 2x minus 1 as my rule. Yeah, let's go ahead. Let's stick with that table of values as our strategy. I think that actually helps a lot. So if x is actually, let's pick a number, some numbers less than 1, like -2, -1, and 0. That's 3 points, right? And so the rule is going to be 2x minus 1. So 2 times -2 minus 1. So that's -4 minus 1 is -5. -1 minus 1. That's -2 minus 1 is -3. And then 0. So that gives me -1. So if I plot those, 1, 2, 3, 4, 5. -2, -5. -1, -3. 0, -1. So there's my first 3 points, and there are 3 points that work for the first function. Let's put in the border point. I want to include the border points in my table of values.
How did we plus negative? Oh, I see.
So what happens at the number 1? Which rule am I using? First, second, or third rule? Why the second rule? Is 1 less than 1? Is it less than or equal to 1? Yes. So at number 1, the rule is -7. Let's pick 3 more points in that range between 1 and 8. So 2, 5, and 6. If x is 2, that's still the second rule, right? So what's the output? -7. How about 5? One, 2, 3, 4, 5, 6, 7. So for 1, 2, 3, 4, 5, and 6, those are all my points down there. So
These are all closed dots right now.
right now, yeah, right now everybody has a closed dot. So I haven't really filled in the unknown gap yet. I haven't talked about what's happening as I go from 0 to 1. I haven't talked about what's happening when I go from 8 onto something else. Remember, this is the point 1. This is the point 8. What happens at point 8? Oh, sorry, that's 7. This is 8. What's happening at 8? Am I using the second rule or the third rule? Is 8 less than 8?
No,
Is it greater than or equal to?
yes.
So I'm using this rule now. So that's half 8 plus 4, which is,
How do you get the?
again, 8 is my answer.
How do you get the +4 though?
Right there.
That's a 4.
That's a 4.
I thought that was a y.
Nope, that's a 4. And then let's get 2 more points to round this out. So 10, so half of 10 plus 4 is 9. And half of 12 plus 4 is 10. So 1, 2, 3, 4, 5, 6, 7, 8. So at 8, I jump up here to 8. There's 9. And there's 10. So there's 8. There's 1. So I still have a little bit to go before I can fill my graph in, but you can see here are the borders that mark off the piecewise function. I got them marked on my graph. The last thing to do now is to fill in the gaps. This one starts strictly on 1 and keeps going. It goes to 8 but doesn't include 8. So there's my open dot to show that it doesn't include 8. Here's my closed dot to show that it does include 1. This one starts directly on the 8, so I make a big solid closed dot right there at the 8 to show that that's included. And then it keeps going. My last one now is this first guy. It goes up to the 1 but doesn't include it. So let's go up to the 1 but don't include it. Yeah. And there's my graph. If I take a look at what I did over here, guys, the important thing to think about, there are my border points. Here are 3 points in each of the regions. So that's kind of your general strategy with this. The plan to draw the graph is to pick out the borders, and then test 3 points within the borders. What questions can I answer about that particular problem? Yeah. My best advice is always pick. See how this goes up to 1, and then we go from 1, we pick up there. So definitely test 1. Then pick 3 numbers that come before it. Then 8's another border. So do 8, and then pick 3 numbers in that range, and 3 numbers beyond it. It's a little easier when you only have 2 functions to play with. 3 is pretty tough, but 2 is generally easier.